today's problem from ordinary differential equation, and this is a linear non-homogeneous differential equation with constant coefficient. Right, now we clearly say that this differential equation has two portions. One portion is complementary function and another portion is particular integration. So the general solution is y, this is equal to yc plus yp. This is complementary function and this is particular integral. Okay, now we find out complementary function and particular integral one by one. We let y, this is equal to c into e to the power mx be the trial solution. Okay, and clearly if we find out here dy, d square y and put them in left hand side, then we get the auxiliary equation. We directly write here auxiliary equation. As what is the auxiliary equation? Auxiliary equation we get by putting d equal to m in the complementary part, that is m minus 1 whole square into m square plus 1 whole square, this is equal to 0. So we get here m equal to 1 1 because m minus 1 whole square equal to 0, so m equal to 1 and 1. And from here if we put m square plus 1, this is equal to 0, then we get m, this is equal to plus minus I and again plus minus I because this is equal to 0. Okay, so we get two real root which are repeated and 4 imaginary root, but every root are repeated 2 times. So the complementary function, that is yc, is given by, we write this as a into, this is e to the power x, a into, since this is the repeated root, so a plus bx into e to the power x. This is for the real root. And for 4 imaginary root, we get c plus dx into cos x plus e plus fx into sin x. Okay, so we get the complementary function. Now we have to find the particular integral. What is the particular integral? Particular integral is given by yp, this is 1 by f of d into x. Okay, this is the formula of particular integration. And here we see that f of d means this d minus 1 whole square into d square plus 1 whole square, and x means e to the power x plus x. Okay, now divide it into 2 portions. We write again d minus 1 whole square into d square plus 1 whole square e to the power x, and the second portion is d minus 1 whole square into d square plus 1 whole square into x. Right, now we see the rule of finding particular integration if here e to the power x is present. 1 by f of d into e to the power ax, which is given by e to the power ax by f of a if f of a not equal to 0. Okay, that is here we write x, this is 1 into x, so we get a equal to 1. If we put d equal to a, then if the factor is not 0, by putting d equal to a, then we can put d equal to 1 here. Otherwise we cannot put d equal to 1. And the alternative rule is if f of d equal to 0, then we get e to the power ax in the left side and we replace d by d minus a and 1 here. Okay, so we get the calculation as here if we put d equal to 1, then this term is 0, so here we put d plus a minus d plus a, this means 1. sorry, this is not correct rule, this is plus a. Okay, d is replaced by d plus a. So here we replace d by d plus 1 and whole square. And but in this case, if we put d equal to 1, then this is not 0. So we get from here, this is 1 by, this is given by 1 square plus 1 whole square, and e to the power x in the left side, and we write another 1. This is the function which operate on 1 by d square. And the second portion is, for the second portion, this rule is not applicable because this is x, and in this case we apply the formula 1 by 1. The first formula we apply is given by d minus 1 whole square into 1 plus d square whole to the power minus 2x. And we know that the formula 1 plus x whole to the power minus n, we write here, this is clearly 1 minus nx plus n into n plus 1 by factorial 2 into x square and so on. Okay, this is the infinite series expansion. Now we write that e to the power x by, this is 2 square, this means 4, and this is 1 by d square 1, right? And here we get 1 by d minus 1 whole square, or we write this is 1 minus d whole to the power minus 2, because if we take common minus 1, then we get here positive sign because this is square, and 1 minus d whole to the power minus 2, and expanding this we get 1 minus, this is 2d, 2 not d, this is d square, and plus so on x. Now if we operate x on this, we get, and from the first term we get e to the power x by 4 and 1 by d square, 1 by d square into 1, this is 1 by d into integration dx, this is 1 by d into x, and again integration x dx, so x square by d. 1 by d means reverse of derivative, this is integration, so we get from here, this is x square by 2. Okay, this is the first term, and for the second term we again expand this, this is given by 1 plus 2d, because the expansion of 1 minus x whole to the power minus n is given by 1 plus nx plus 2 so on, plus if we write the third term, not required to write, but we write here, this is 2 into 2 plus 1 by factorial 2 into d square and so on. All terms are positive, and from here we get only x, because 1 into x is x and 2d square into x, 2d square into x, this is the derivative 2 times of x, this is obviously 0, and all the other term derivative are also 0. Okay, so we get only x here. So the result is, this is e to the power x into x square by 8 from the first term, and from the second term we get, this is x plus 2 into dx, this means 2. Okay, so this is the particular integration, that is yp. Now we write the value of yc, this, and yp, this, we get the final result. So general solution of given differential equation is y, this is equal to, we write a plus bx into e to the power x, c plus dx into cos x plus e plus fx into sin x plus x square e to the power x by 8 plus x plus 2. Okay, and this is the final solution of the problem. Very interesting and important problem from linear non-homogeneous equation. Right? Thank you for watching.